harnessing the innovations of LogicProgs in BCI technology. Brain-computer interfaces (BCI) are increasingly used in a range of industries, from medical to gaming, and the potential for further development is vast. A BCI is a two-way communication system between a person and a computer, allowing the user to control the computer using brain signals. BCI technology is being used for a variety of purposes, from controlling prosthetics to controlling games. And many of the innovations that are being made in the field are due to the use of LogicProgs. LogicProgs are programming languages which allow the user to create complex algorithms for the BCI system. By harnessing the power of these LogicProgs, BCI technology is being pushed to new heights. One of the primary uses of LogicProgs is to enable BCI systems to recognize different patterns of brain activity. For example, by using a LogicProg, a BCI system can be programmed to recognize when a user is thinking of a particular object, or when they are performing a certain action. This information can then be used to control a device or to trigger specific responses. This type of pattern recognition is essential for BCIs to be able to accurately interpret the user's intentions and to respond accordingly. LogicProgs are also being used to create more complex algorithms for BCI systems by programming in different rules and conditions. The BCI can be trained to respond to a range of inputs. This means that BCIs can be programmed to respond differently depending on the user's intentions. For instance, a BCI system could be programmed to respond differently when a user is thinking of a particular object or when they are performing a certain action. This type of flexibility is invaluable for BCIs that are designed to be used in real-world applications where users may not always have the same intentions. Finally, LogicProgs are being used to create more sophisticated BCI systems by programming in different rules and conditions. More complex systems can be created which are able to respond to a range of inputs. This means that BCIs can be programmed to respond differently depending on the user's intentions and the context of the situation. This type of flexibility is invaluable for BCIs that are designed to be used in real-world applications where users may not always have the same intentions. Overall, LogicProgs are playing a vital role in the development of BCI systems by harnessing the power of these programming languages. BCI systems are becoming more and more sophisticated. This means that BCIs can be used for a variety of purposes, from controlling prosthetics to controlling games. And the potential for further development is vast by using LogicProgs to create more complex algorithms and to recognize different patterns of brain activity. BCIs are becoming increasingly powerful tools for controlling devices and for interpreting user intentions. As the technology continues to develop, the possibilities for BCIs are becoming more and more exciting.